Okay, I think we're live. Hi, everyone. I hope you guys can hear me. Can someone just confirm in the chat if you can hear us? Okay, we are live. Just waiting for people to join. Okay, someone's confirmed. Can hear us. Thanks for confirming, Sandeep, Stephen. We'll wait for a few more minutes to join, for a few more people to join, I mean. We have David Ping with us, the author of the Machine Learning Solutions Architecture, the second edition. David, do you want to kick us off by maybe speaking a bit about what your career has been so far and just a general introduction to yourself?
Sure. Yeah, thanks, Tanya. And hello, everyone, for all of you who have joined. And thank you very much for taking the time. So yeah, a little background by myself. So I have about close to 30 years of, I guess, professional experience now in mostly in the technology domain. And currently, I lead a team of AI/ML solution architect at Amazon Web Services. And my team is mostly responsible for working with customer from or company from different industry to help them design AI/ML solutions to essentially we call transforming their business because AI/ML, right, as we all know, it's really a transformative kind of a technology. Being with AWS for about 9 years now, just over 9 years. I kind of started out as a cloud architect, when I initially joined AWS because back then cloud was really was the just emergent, right? Was the interesting thing for a lot of people, and then things start pivoting into AI/ML. So I made an effort to say, what, I want to do something different. So I kind of pivoted my own technical career right into AI/ML. And since then, I have been kind of a functioning in the specialist organization or role since then. Prior to that, I spent many years actually working in financial services. I was in different roles. I was a chief architect, head of application development, developer, development manager, you name it. All the different roles that you would imagine from I guess tech person in the background. Mostly building, designing enterprise financial system, right, for investment banking. Also did about a few months or about a year in the insurance industry. Prior to mostly focused on investment banking, I guess. But I started my career actually as a software engineer at Intel. So I was working on device drivers, way many years ago. So that's my background. So I've been really enjoying my role, my career so far.
Sounds like a very impressive profile there. And you have such a long career as well. So folks, if you have any questions for David, you can start putting them into the chat. In the meantime, I just have some general questions for you, David, that I will ask you. Hopefully by then we have some questions from our audience as well. So I'll start off with a very general career-based question, which most people might have. Imagine someone who's looking to be a solution architect. What would you say are some of the desired qualifications, both educationally and work experience-wise? What are some of those desired qualifications? And for someone who's already a machine learning solutions architect, what happens next for those kind of individuals? What comes next in terms of professional growth?
Sure. Yeah. No, great question. I mean, to a certain extent, I can almost relate, to my own experience. But I also want to say that the field of AI/ML solution architect has changed, quite a bit, right, in the last few years. first I want to talk about, maybe just, the kind of a different AI ML solution architect role that I'm seeing now versus what I'm seeing before.
Right.
So I guess
Right.
when I initially started about 6, 7 years ago, right, in this domain, there is not that many specialization, right? I would say everyone is, I call them like, maybe general industry AML solution architect. And that means
Mhm.
that person, you know, need to know a little bit about data science, need to know something about ML engineering, need to know about
Mhm.
enterprise architecture, need to know something about the business, right? So you're
Right.
essentially, kind of a jack of all trade to a certain extent. And that kind of role still
Mhm.
exists, right? So I would say in my current role, that's and my team, that's essentially what we're doing, right? We're jack of all trade. We go from the full life cycle from the business
Mhm.
domain all the way to technology domain and operational domain.
Mhm.
But the field of AI/ML solution architect has also specialized. So you have a AI/ML solution architect focus on a particular services, for example, right, or products.
Mhm.
It could be
Mhm.
GenAI product. It could be a computer vision product, right? Because those
Mhm.
product become so capable and deep now, you need a specialization in some of those, right? So that's kind of
Mhm.
one type. I guess in addition, right, to what I'm talking about, a general kind of a specialist from AIML perspective. But also you have specialists focus on maybe more of a technical domain, right? So you have
Mhm.
let's call the product specialists on AIML solutions or products, but you also have NLP specialists, right? You also have computer vision
Mhm.
specialists. So there's all different specialization that start to emerge. So it
Right.
really depends on where do you want to get into, right? But there's some general
Okay.
rule of thumb in terms of how to get started, right? But first, let's talk about the high level qualification, right? To perform,
Mhm.
let's say across all those different roles. Number one, you need to develop some sound fundamental understanding of the machine learning theory, right?
Okay.
Does not mean you need to be a algorithm developer creating those new models, new algorithm, but you need to be
Mhm.
familiar with how machine learning works, for example, right?
Right.
How does a machine learning model train? How do
Right.
they really make predictions? What does that mean, right? So you need to understand because that's important for you to understand how those can be applied to different scenarios. So that's number one.
Okay.
uh,
Okay.
as a solution architect, especially in machine learning, a lot of time it's really about solving business problem because yes, you're going to be responsible for building, for example, a machine learning platform, which could be of its own complexity. But many
Mhm.
times it's about, oh, you're essentially advising or telling, let's say, your stakeholder about how to build a predictive solution, right, to solve a business problem.
Mhm.
So then they say, hey, I want to, I don't know, as simple as I want to, reduce churn, right, in my customer base, or I want to improve user experience. So what does that mean? That means you want to have some good understanding about a business domain you're working with, right?
Mhm.
Because ultimately, solution architect also need to function as a translator, right? I see that as a very important role, is because you have the business people who kind of live in their day to day kind of business workflow. They might not have the connection, right, with the technology angle of it. As a solution architect, you would be the person who need to advise them. Oh, this is kind of the business process, challenge you want to resolve, and here is a potential solution from machine learning perspective, right? And then, of
Mhm.
course, as you get into implementation, you talk about the engineering and all that. So I would say, business understanding, it's another key element or aspect of your background. Uh,
Okay.
and then I would say the third high level is really about just general architectural kind of a background, best practice, knowing, because, you know, building a model is one thing, right? That's what we're talking about. You need to have machine learning kind of fundamental, right? Business kind
Right.
of tie those together, but ultimately to realize that you still have to put a technology system together, right? Now, a technology system
Right.
together, you start coming
Mhm.
into the traditional, I guess, technical architecture, right? You talk about scalability, you talk about security, you talk about performance, right? You talk about
Mhm.
redundancy. right? All that start coming to play. Uh,
Mhm.
so that I would say is another area of kind of a background you need to develop. So I'll say those are maybe the three main area you need to develop. But then it depends on your
Mm.
specialization, right? So you say, hey, I also want to become a specialized person in this particular, product and services.
Okay.
And then, of course, you develop in-depth understanding about how that works, its function, its feature, what kind of problem can it
Mhm.
solve, where you can,
Mhm.
implement or deploy that kind of a product or solution into a broader system. And those systems could be
Okay.
a variety of different things. It could be a machine
Mhm.
learning platform, right? That's geared towards
Okay.
data scientists and ops engineer for deployment, or it could
Mhm.
be geared towards end users in terms of application they use right away, or it could be geared towards developer who want to essentially call your AI ML services as part of
Mhm.
their kind of a application development, right? Uh,
Mhm.
so that I guess that's the specialization side, of things. Of course, if you become like an NLP expert or computer vision expert, that means you need to just go deeper, right, in terms of understanding, what are the, again, still going to the fundamental, right? What are the leading model algorithm, right, that you can use in that space? What kind of machine learning or computer vision problem, NLP problem typically to be solved? Where do they apply in different industry? How do you
Mhm.
optimize things to make sure that they work, to the extent you want to work? So I would say those are, again, depends on the past, different background, kind of you would need, right? Uh,
Mhm.
so you're saying, well, that's a lot. How do you get started, right? So somebody new,
Yeah, true. Mhm.
somebody new. Uh, so this is where maybe I can, relate a little bit, with my experience. LB is, it's different now.
Mhm.
So I will
Mhm.
say, number one, it's very important for you to have a strong interest in this area, because
For
uh,
sure.
it is a quite broad and deep domain. And a lot of time when they get started, it's like, wow, there's too many things. Like, where do I start? So I think where you want to start is reading some books, watch some, kind of education series, just understand again the machine learning aspect of it, right? But maybe don't go too broad. Like, focus on some really common, machine learning theories, right? Or
Okay.
like how does machine learning work, and like the basic algorithm. Because once you develop that high level intuition, you would start appreciating, right, the domain a little more, right? So I will start with
Mm.
that.
Okay.
uh, and again, trying to learn as much as possible. Uh, but then also identify opportunity in your current workplace to apply it.
Mm.
So nothing will replace hands-on experience in a real problem, because
Mhm.
otherwise you listen to the theory, theories, you kind of watch you read the book, you're gonna quickly forget, and
Right.
without the and people say, oh, but David, I'm not in this area. Like, how do I actually find a problem? But given AIML is so prevalent now, you can almost find a problem to solve with AIML in any discipline now, right? Like, if you're in
Mm.
HR, you probably can find a problem to solve using machine learning, right? If you're in sales, you can find a problem. You're in engineering, there's all that, right? Because what I'm saying is, once you develop that intuition, you say, hey, now I can build something. Let me identify a problem, and you might also be able to find some good data set, that relevant to your business, like you're working in,
Mhm.
and trying to take a leap, saying, hey, maybe talk to your teams, hey, let's try to do something different. Let me, apply some machine learning to this problem, using the data. Can we, solve this better, right? That
Mm.
will help you tremendously in terms of ramping up or getting started with that initial kind of learning, because that's when you really apply your theory. I mean, your practical experience with learning, and I personally found that to be the most rewarding as well. Uh, and then another component, which I also found to be really, really important, is actually writing something. Again,
Okay.
think about a problem you want to solve, because writing a lot of time it's not simply about you sharing your knowledge one way. It's really mutual learning, because as you start writing, as you're thinking about how do you present certain topics, you're going to find out there's so many areas that you don't have knowledge about, right? And that is a forcing function for you to truly learn, about an area, and force you to dive deeper into a certain area. So then, you're not just talking about things at a superficial high level. You essentially, can go both, you can go deep, right, in the area that truly matters. So I found those to be a really good way of ramping up, right? So, that's
Okay.
what I would recommend. Again, reading some theories, apply something in your real life, try to write something about a topic you care about, you're interested about. I think that should prepare you pretty
Mhm.
well in terms of, again, getting the fundamental, and then, see if that would land you somewhere. If become a ML solution architect, it's your career aspiration. Just say, now you have that three kind of credential to offer. Will
Mhm.
somebody, give you opportunity to try, right? A lot of time, again, as I mentioned, again, it does not have to mean you go outside look for a role, right? You can evolve your own role within your own organization to do something in that space, as long as you can identify a problem, right, to solve. So I would say that's for folks who are starting out, right?
Mm.
uh, and then you have people who are, to your point, they are already ML solution architect. What do you
Yeah.
do from there, right? I think, typically, we'll say, hey, if you're experienced, there are usually two different paths, right? You can say, hey, now I want to pivot into management. I want to lead a team.
Mhm.
I want to manage a project. That's, so that means you just have to acquire some new knowledge if you don't have it. uh,
Mhm.
or, you just go really become deeper and broader in the AI ML domain space, right? So it's really about how do you define the influence of your impact or your impact, right? So maybe right now say, hey, you kind of a solving problem at a task level. Say, hey, I'm solving this problem at this task.
Mhm.
Now maybe you're elevating that. Now you're solving that problem within a larger, kind of business functions. You're directly relating your problem, your solution to the business outcome, right? You're designing a system that a lot more strategic, right? And AIML, which is great in a sense where, because given the importance of it, it tend to have a lot of enterprise strategy around it, right? So as a solution architect, you're always going to have this different layer of or level of problem you want to solve, right? Start from a very easy one to really enterprise challenges that you need to solve, right? Both from engineering and just from, potentially, just, even machine learning model perspective, right? Again, does not mean you need to
Right.
build those model, but at
Mhm.
least you have the knowledge to say, hey, how do I stitch everything together that truly
Mm.
solving and kind of enterprise scope challenge. So I would say that's another way for you to think about how do you advance your career, right? Is how
Mm.
do you think about the scope of your work and the impact of your work,
Right.
either within the same company or at a different company.
Right. Thanks for sharing such comprehensive thoughts on this aspect. I hope everyone's taking notes because this is real gold out here that David's handing out. Oh, good to see we've got some questions coming in, David. Um, Give me a second. You should see the question on the chat below.
Sure.
Is explainable AI, responsible AI, considered its own specialization, like computer vision or NLP? Or should someone interested in XAI focus on XAI in a specialization? So I guess basically the question is
Yeah.
explainable AI considered its own specialization?
Yeah. I would say over time it will. The reason I'm saying that, so to a certain extent, especially with, Gen AI, right? It just started emerging. So, well, I'll give it two answers, right? So, number one, uh, does my team kind of work, in the whatever I talked about from a special perspective, as well as the
Mhm.
explainable and responsible AI? We do, right? Because that's just nature of our role. Like when we work with, let's see, on a problem, right? That kind of problem comes up, so it
Mhm.
does mean you need to have some sort of a knowledge about, I don't know, how do you
Mm-hmm.
explain your model, right? What are the different techniques, right? Is it Shapley? Is it Lime?
Right.
How do you address some of the privacy? So you need to have that kind of a high level, good enough understanding and ability to explain.
Mm-hmm.
But this area has become so increasingly important. I do see this
Mm-hmm.
become a specialization of its own, right? Because
All right.
essentially explainable AI, responsible AI, or all the different factors around it, going to be so important in many of the production deployment. So simply be able to explain at a high level is not going to be sufficient anymore, right?
Okay.
So especially for some of the regulated industry like financial services, HCOS, you need that deep domain expertise. So I do personally see that will become a specialization of its own.
Okay. I
But
hope David answered your questions.
but
Oh.
those are related though, right? Because a lot of times say,
Mhm.
hey, when you talk about responsible AI, explainable AI, right? It's explainable AI on top of a CV or on top of NLP or on top of traditional predictive. So it's almost, you still need to have that, fundamental understanding, that machine learning
Mhm.
theory and specialization that I'm talking about, and
Mhm.
knowing how different explainable AI, responsible AI kind of apply, right, to those different tasks. So,
Right.
so that, so yes, it's specialization, but does not mean you don't need to
Mm.
have, some sort of domain expertise in the other area, because those two are related.
Okay. Makes sense. I hope your question was answered, Stephen. I'll move to our next question here by Sandeep Patil. It's something similar to what we were, anyways, planning to talk about, David. Um, would you be able to give us one sample problem and how would you solve or design it
Okay, sure.
at a
So
very high level?
yeah, yeah, I can talk about maybe in my early career, right? I mean, early AIML career. In general, AIML still. I mean, it's old, but it's not still not that old, right? In terms of how everything started truly happening. So,
Mm-hmm.
so one of the earlier project that I worked on was an interesting project, right? A lot of time we think about machine learning is deep science, mathematics, formula, right? It's all kind of boring stuff, and it doesn't have to be. Let me put it this way.
Mm-hmm.
So the problem that I had to solve was related to a sports analytics, right? So working with
Okay.
the sports league, they're saying, hey, we have this player tracking data, and we want to be able to solve some interesting sports analytics problem, right? For example, I want to
Mm-hmm.
predict the route of a person can be running, and many other things. So the way, I guess, so that was the problem statement, if you will, right? And it would say, hey, well,
Right.
it's easy, right? Just apply some machine learning and get it working, which is exactly what I did initially. So, let me just get whatever the raw data, think about, how this data should look, and feature engineering and processing certain way, and just, fit that through some sort of model, and thing
Mm-hmm.
didn't work, right? We struggle didn't work. And it turns out I really had to learn about in this case, that particular game, to truly understand those data and be able to process the data, transform the data in a way that I can actually fit the model that eventually solve the problem. So,
Mm-hmm.
so in this particular problem is, for example, right, like you have this really noisy data, right? Those
Right.
spatial 3D spatial data that are, that are continuous across many different events. So now you have to understand, what does each event means? How do you segment those data based on different events? Which
Mm-hmm.
portion of the data you truly care about, right? That are truly relevant, that are considered signals, right,
Right.
to what the kind of problem you're going to solve.
Mm-hmm.
Now, once you understand that, oh, how do I normalize the data in a way that I can standardize this feature and fit into this machine learning model that I can solve, and now you tried out different machine learning models. Hey, maybe initially try something kind of fairly straightforward, like XGBoost, for example, right? Or basic, kind of classification. And you realize, oh, that doesn't really work. Why? Because there's many other kind of a slightly different modality or multi-dimensional information that was not captured really well, right, by that. So, now what else can I do about it, right? So then I end up designing, creating a kind of a deep learning or neural network algorithm, right? That essentially will be able to take those data in different modality and different special components, and then trying to train it, and that essentially worked. So the learning, right, from this particular, I would say the key learning actually about this is two area. Number one is develop a good understanding of the business and the data, so you know what those mean. Very, very super important for machine learning project. Second is the iteration aspect of it. It's unlikely you're going to be able to, I mean, again, this is if you want to train a model, right? It's unlikely you're going to train a model that works, right away on the first try, right? Even same model, you're going to have to tune many, many different times. And many different times, you also have to try many different way of, in this case, of fitting the data using different algorithm to do it. So those are the two main learning I got, from this one. But it's yeah. So that was I guess the a sample problem, I guess, that I like to offer. But to some extent, it's no different from maybe many of the common, I guess, principle, right, that you have, or best practice you have been hearing if you're already kind of in this field.
All right, makes sense. I hope, Sandeep, that David was able to answer your query. Moving on to our next query from Pablo. From where you stand, David, which are the most scalable ML algorithms? Which is the one that balance metrics, costs, and security?
Yeah, well, there's no easy answer for this one. It's all very situational, right? It really depends on what kind of problem you want to solve. Sometimes, hey, for example, you need to have explainability, right? Well, then you would have picked something basic like linear model, linear regression, logistic regression, because now you can explain it. Any changes in your input value or coefficient, you kind of understand the output, and those also tend to be fairly fast as well, right? So that would be one kind of a consideration. But if you say, hey, my problem is really about, not just the basic linear kind of relationship, I have a lot of non-linear relationship that is so important, for me to figure it out, then you want to consider one of the more advanced, right? In this case, typically neural network, but neural network tend to be slower, right? It trains longer. But there are, of course, there are ways to make them faster as well. You can do, I guess, the optimization of the model and all that. But then you're gaining the benefit of detecting a lot of hidden relationship or non-linear relationship, but sometimes at the cost of bigger model size. And what does bigger model size mean, right? It potentially slower, and it could be more costly to run as well, right? So it's really a balance. So I will say, in terms of how do you make, maybe that's really the question you're asking. How do you decide which algorithm to use, right? But I think you had the right kind of some of the right factor to consider, right? So for example, the model metrics is important, which means is the model performant from accuracy perspective, or any other kind of loss function you're trying to optimize. Is the cost within your defined constraint, right? How much are you willing to run this or to train this? What this model, what kind of mechanism do I have to secure the model, right? There are many different ways of securing the model, right? You can't, sometimes the model itself can be, very resistant to a lot of adversarial kind of attack, but some other model might not be. Now, if you don't, you can always put additional security layer on top to secure it. So really the recommendation here is consider your outcome, consider all the different factors that matters to you, figure out which one is more important, which one is less important, and then make decision based on that. And there's just going to be many different choices, potentially depending on the problem you're trying to solve.
All right. I hope David was able to answer your question, Pablo. Um, do we have any more questions? So, for everyone who's just joined us, feel free to ask David any questions you want about machine learning solutions architecture, designing systems. Um, Throughout the live stream, I will do a draw, and two of you lucky winners will win a copy of David's newest edition. So, feel free to pop in your questions and tag pact with a hashtag pact. So, that should enter you into the draw. Um, I have a question for you, David.
Mhm.
In this new edition, since I edited it, we did a lot of designing. We designed systems, we designed solutions, we designed
Mhm.
architecture. For those of
Mhm.
us who haven't picked up the book yet or haven't gotten to the part where we do start designing things yet, can you walk us through at a very high level a few key considerations to keep in mind when designing a machine learning system?
Mhm. Sure. Yeah. I guess when we talk about machine learning system design, I kind of group them into two main category, if you will, right? One
Mm-hmm.
is building a machine learning platform, and
Right.
second is really designing machine learning applications, right? Essentially have a model running within application that does certain things, right? Uh,
Mm-hmm.
Usually, the primary aspect of for focus, at least for solution architect, is more on the machine learning platform side, because that's really where the majority of the work happens, right? Because once the model is trained, then it
Mm-hmm.
really just become a traditional machine learning or application development, where you talk about how to
Right.
embed deployment or call API. So let me talk about the machine learning platform side of the considerations, right? Uh,
Okay.
so number one is you need to think about the persona for your platform, right? So
Okay.
unlike end user application, you typically, for example, only target the end user, right? Because they get a UI, they interact, and essentially that's how you think about some of the application from usability and scalability and security perspective. Uh, Machine
Mm-hmm.
learning platform tend to have more than one persona, right? So number one is the data
Mm-hmm.
scientist or
Right.
machine learning engineer. And what do they use the machine learning platform for? They use that to experiment. They use that to build different models.
Mm-hmm.
They use that to deploy to different kind of endpoint or target environment for essential serving. Now, for the experimentation part, some of the key considerations are you want to make sure that um, the environment can support just a different modality of data and different volume of
Okay.
data, right? Machine learning, that's one thing which is unique about machine learning platform is they take on data of different modality, and sometimes the data volume could be huge, depends on the problem you want to solve, right? So for
Mm-hmm.
experimentation, you want to make sure that you have a data system that can support that kind of inputs or managing those kind of data.
Mm-hmm.
You also need to have a data science experimentation environment, right? Typically, this would be like Jupyter Notebook environment, or Jupyter Server, or any other
Okay.
IDE that you think your end user will be using. So that
Mm-hmm.
essentially is another consideration. And how do you really provide a scalable and user friendly environment so that they can quickly doing a lot of different kind of experiment, as mentioned earlier, right? Machine learning
Mm-hmm.
building model is really about many different experiment and iteration. So having an environment that gives them the ability to iterate really quickly, that also means the ability to track all the different experiment, right?
Mm-hmm.
All the different runs. So have a capability to do that. Uh, but also give them the flexibility of different compute, because machine learning model, and again, this is quite different from maybe traditional machine application development, where most applications just run on GPU on a CPU kind of environment, right? And depending on the performance, latency, that would be the key consideration. For machine learning model, depending on the model architecture, right? It could be a GPU, it
Mm-hmm.
could be using CPU, it could be using what do we call special silicons or customized silicon for solving different problems. So depending on understanding the scope of all the different variety of problems you want to solve, and make sure your machine learning platform can provide that kind of compute resources depending on the needs, right? For experimentation. So that's the experimentation part. Now for the training part, what's important is mostly about scalability, because that's where sometimes you might train the largest model, right? So, we all know, right? The train, for example, this generative AI model, could take, weeks or months or even years, depends on, when you decide to do this, right?
Right.
So that means having a really robust, highly resilient training environment that can cater to different large model training needs. It's also very, very essential. But also having the ability to inventory or have a catalog of this model that you trained is also important. So you have a lineage of all that information, all the way from data to your model training, to the different hyperparameters, to the metrics, right, you want to track, to the different, other evaluations, kind of a tooling you want to be able to apply to it. And lastly, for data scientists, sometimes it might be to the data science role, but sometimes they also need to deploy for testing. It's a deployment environment, right? That deployment environment could be for, experimentation, it could be for development, but more important is for the production infrastructure. So the complexity in that environment is also dealing with different variety of different model size, complexity, the latency you deal with. There's many different, inference server you need to consider, right? There are many open source. There's also many commercial kind of software you need to consider, like which one would perform, most cost effectively, for example, for your kind of problem statement. So I would say those are the three main things from that perspective. And ultimately, there's one more important thing, which we all heard about, is the MLOps, right? So it's the automation aspect of the whole thing, right? Because that gives you control, that give you governance, that give you confidence actually ultimately about something you train, it's fully documented, fully automated, and the human error is minimized because everything is automated. So that's, I guess, another key component. And of course, the other things such as security, monitoring, right? We talk about experimental AI, right? Those are additional consideration from a tooling perspective. How do you consider this tool, make those available in your machine learning system so that all those different needs can be addressed.
Right. While answering one of the earlier questions, David, you said there are several specializations, several projects that solutions architect work on. Speaking of machine learning projects specifically, how do those differ from these other specializations? I think you named a few, but if you could name those again and then chart out like a difference between machine learning and those other specializations.
Yeah. So maybe I'll talk about in the context of solution architect as well, right? Because it could mean different things depending on the role, right? So let's see, how does this differ from, let's say, a cloud architect, right, versus a machine learning architect? There are a lot of similarities, if you will, right? Because I talk about some of the engineering aspect of things. Those are similar, right? You still have the design system that's highly scalable, secure. You still have to think about, like in the context of a cloud, like AWS, for example, right? The networking aspect of it, the storage aspect of it, right? So all those actually remain the same in terms of consideration. Where the main differences, I would say, is the machine learning theory side of things, the model side of things. So that's one consideration. Now, as a machine learning solution architect, in addition to considering those infrastructure, right, kind of consideration, you also start thinking about, what kind of model should I be using, right, depending on the use, right? So if my user want to have a model that can be easily explained, well, that's one consideration. If my user saying, explainability is not a big concern, I'm really looking for that best accuracy, well, that's going to be a different consideration, right? So that is one of the differences, thinking about, right, how do you make decision on the choices of the model? Another area I would say is actually similar on the inference side, right? With traditional machine learning or traditional solution architecture, you say, hey, here's a compute, you run whatever, the software on it, and that's the extent of it, right? You kind of essentially provide the compute aspect to the business problem. But here, if I have this kind of model, and I want to be able to achieve certain throughput, certain latency, how do we consider the hosting architecture, right? What kind of inference server should I be thinking about? So that's one aspect. But also there's other aspects, such as, how do I know this model is working in production, right? So in a non-machine learning system, things are fairly deterministic. You essentially know, given an input, and what kind of output you're going to be getting, right? So usually after you finish your QA, right, or testing of your application, you essentially have a pretty good idea how it's going to perform in production. Machine learning model is different, right? Sometimes you could have sign-in failures, right? When things fail, how do you know it's failing, right? So then there is that additional model monitoring aspect of things. How do you know the model is degrading? How do you know it's doing something out of distribution? How do you actually looking at the input data to make sure the input data is conforming to the training data, right, being using? Now, if it's out of distribution, how do I handle that, right? So there's those additional consideration, which I mean, of course, there are many others as well, but those are some of the differences you would, between, I guess, ML a project, in this case, ML solution architect, and the traditional solution architect.
All right. Thanks for sharing your thoughts on that. I think it's time to do a draw. We have a couple of questions piled up. I'll get to those soon. But before that, let's pick our first lucky winner, who stands a chance to win the second edition of David Ping's The Machine Learning Solutions Architect Handbook. And begin. Oh, great. The winner is Savitri Banka. Savitri, do get in touch with me on LinkedIn, and I'll make sure you get your free copy of the Machine Learning Solutions Architect Handbook, the second edition. Congratulations, Savitri. We have one more round of draws to pick one more lucky winner. So please do hand in your questions in the chat, and remember to tag #pact. That should enter you into the draw. Oh, we have a good question here from a Jane. Congratulations on the new edition, David. What are the interesting new additions in it? And do you have a favorite section that you had the most fun writing about?
Right. No, thank you for that. Thank you for that question. Yeah, some of the newer addition between this one and the first one is I have a more extensive coverage of AI risk, right? In the old edition, I cover some high level, from a governance perspective. So in this new edition, I cover a little more extensively. Talk about different scenarios, different consideration for mitigating AI risk, but also cover a lot more in the adversarial side of the AI risk, right? It's not just simply, how does the model behave, right? To a certain extent is the risk, but also, what if there's a adversarial attack against the model, right? In terms of stealing the model or getting the model to behave incorrectly or, in a wrong way, right? So I cover that. That's one. I have a chapter now talk about, how do you think about advance in the maturity of AI/ML from organizational perspective, right? So as a large organization, how do you understand where you are, and how do you think about advancing your capabilities, right? From people, technology, and process perspective, and what do those different maturity look like in terms of how companies should be assessing themselves. So that's another one. And then 2 chapter on generative AI, and the first chapter is really about how you navigate the project lifecycle of generative AI. Again, it's still new. This is still a kind of an emergent field. People still trying to figure things out. So
Right.
so based on what I kind of have learned, right? I kind of wrote my own view of it. But also the second part is, in addition to navigating the project lifecycle, how do you think about actually building the GenAI, system, like GenAI platform to support, but also some of the use cases that I think, people are, a lot of companies are exploring, right, across different industry, financial services, healthcare, for example, and media entertainment. So I would say those are, the four main area of the new book. And of course, some previous chapter have also been updated, for example,
Yeah.
UC section, there are new use cases for different industry.
Right.
And in the algorithm section, there's new algorithm that cover generative AI, both for language based as well as image based or diffusion models. There are also update in the ML ops or ML platform design section for both open source and managed services. So yeah, actually here is kind of a to talk about what are the system design consideration, right? A lot of time, one key design consideration is how do you make decision between build your own, which essentially using open source, versus building on top of a more of a managed platform, right? There are pros and cons of those. So I cover it, with updated kind of like guidance and an example in both, with new tooling and framework. But also the AI services aspect of as well, where some new AI services, as I mentioned, right? Depending on your background, right? Because not everyone only want to work on the platform or the algorithm part of it. They just want to think about how to leverage existing AI services to build intelligent applications. How those different services can be used. What are the capabilities that are available in those AI services that it can use to build different applications.
Right. Jane, I hope David was able to answer your question. There was a second part to that question, which was, which is your most favorite part or chapter that you enjoyed writing? And if I can take a guess, if I can guess what your favorite part was.
Sure.
Was it
take a guess.
the generative project lifecycle?
Yeah, no, I mean,
No?
partly it's yeah, it is. Yeah, I think partly because it's a new thing. Like for me, what I enjoy most is kind of a explore into new area that just emerging. Like there is not a lot of good practice. You have to dig deep and look across all the different area to figure it out, formulate your own opinion. Right? There's almost no right or wrong. So I kind of enjoying that creative side of this is how I think this how it should be working. But I could be totally wrong, to be honest with you, right? Sometime, right? Because things are moving so fast, So I think that was the exciting part of it. It's like even as right, Tanya and you are like, as I finished the book, so, oh wow, this is already outdated. I need to rewrite this big portion to keep it up to date. So that was both exhilarating but also challenging. But again, throughout the process, as I mentioned, right, sometimes writing is learning, and I feel actually as part of writing, just because you don't really have a lot of written book or material in this domain yet, right? Everyone trying to figure it out. So as you start writing, you think about the problem you want to solve. You think about the challenges you potentially need to face and the solutions. You are essentially learning as part of it. So I like that kind of both the creative part, but also the deep analysis and and the solution part of the section. Yeah.
Right. By mentioning generative AI project lifecycle, I was subtly trying to get you to talk about it, because that was my favorite part while editing the book. Because AI is everywhere, right? Everyone talks about it. We see it everywhere, whether you like it or not. So tell me about the AI generative project lifecycle. What are some of the challenges in your experience that you have faced while scaling and deploying your AI projects? And how did you tackle them?
Sure. So one common thing, especially in the new Gen AI space, it's not too much of a technical problem. And sometimes people say technical
Hmm.
problem is easy to solve. Eventually, we're going to figure it out. Uh, it's actually the business problem, right? Now, there are a lot of enthusiasm about this right now, right? All company,
Hmm.
everyone's doing a lot of proof of concept. They're trying to push out a little pilot, different pilot, but a lot of organizations are struggling to defining the ROI. Like, what does this GenAI solution I'm trying to do mean from business perspective, right?
Hmm.
It's very easy to get a lot of idea. Like, one thing I hear is, oh, we have hundreds of use cases, but I don't know which one to take to production. That
Hmm.
actually is a one of the bigger scaling problem, right? Because when we talk scaling, it's not infrastructure
Right.
scaling. That's easy, right? It's about business scaling in this case.
Hmm.
So that's one area to think about, is how do you establish a use case prioritization framework to think
Hmm.
about what do you want to solve first and what do you want to solve next, right? Think
Wow.
about both from the business return angle as well as the feasibility angle. Just because the business return is
Hmm.
high, but if not feasible, too complex to solve, you probably don't want to tackle that either, right? Maybe just it's a great dream to have, but maybe it's not something feasible in the near future, right? So think about this as like a grid, right? Or kind of multiple quadrants, right? Think about
Right.
that. So that actually is one, and the way
Hmm.
to really solve it is thinking about, right, through those two, I say two basic lens. But again, when you think about ROI, there are many different ways of thinking about it, right? Even if you're defining the business value, there's many different business value to think about. There is the financial business value, there's the reputational business value, there is the
Right.
competitive advantage business value, right? There's all that value,
Hmm.
but somehow you just need to figure out what are the metrics that matters most to you, and then align
Hmm.
them up with what do you think is feasible. And feasibility, there are many different angle of feasibilities, right? There's a technical feasibility, as we know from research perspective.
Hmm.
There's also the skill and talent feasibility within your organizations, right? Just because
Right.
research sense is doable, you need to think about, do I have the engineering and science resources to actually do that myself, or do I have to rely on somebody else to do it? Now, does that somebody else, third party, also have that capability of doing it, right? So I think that
Hmm.
actually is one of the primary one. uh, Another big challenge probably we all hear about, right, is I was with Gen AI is definitely the responsible AI side of thing, or the AI risk, right? Things like
Hmm.
misinformation, hallucination, right? How do you detect them? And right now, right, the common way of addressing hallucination right now, as we all know, right, is really just RAG, right, retrieval augmented generation. Is
Right.
how do you ground your answer with some facts,
Hmm.
right? So that it's definitely one area. Another area is really around harmful content, biases, with the output, and the way to address it is really by building guardrails, right, both for input and output.
Hmm.
So, for example, when you have an input coming in, you want to detect harmful messages, maybe detecting certain topics that are not allowed to be discussed. And when the output goes out, make sure there's no PI information, right, that are being returned. Just implement this guardrail, right, so that
Hmm.
you can feel a little more comfortable, right, with the GNS solution going to production. Uh, Another area is really around. I guess this is more of a technical, but business as well.
Right.
Is there's many
Hmm.
different way of using GenAI model, right, or we call foundation models, right? There's using things as it is. You give it a prompt, you get some response back. That's good, right? You can
Right.
use some advanced technique like zero shot, few shot, in context learning, right? It's a term
Hmm.
to steer the model to behave a certain way. But sometimes that might not be enough. So then, how do you know, or how do you decide what to do next? Should you thinking about fine tuning the model, right, with your own data?
Hmm.
Now, then the challenge comes in. Well, fine tuning require good quality data, right, which is also a challenge.
Hmm.
That's still a challenge, right? Some company have
Okay.
resources to do it, expertise. Some company might not, right? So that's another area, or even going beyond a little bigger. Say, hey, even I think fine tuning or small customization model might not be sufficient, and really as a company we want to have our own capability. Then company just train a lot of model from scratch. So that's also
Mhm.
sometimes a difficult decision point. And this also goes back to some of the earlier question about how do you balance the cost, the performance, latency, and everything else as well, right? Because
Mhm.
this different mechanism have different cost consideration and performance consideration. Now, how do you balance those, right? It's
Right.
also a decision point to make. Um, Model evaluation is still a challenge, right? Especially with a lot of
Mhm.
foundation model that can do everything, right? How do you know? And a lot of the advice I have is focus on the use case and task, right? As good as
Mhm.
those generative AI model they are, like they appear to be like intelligent beings sometimes, like answer, be able to deal, work with you all, on all sort of things. But luckily, right, in many of the day-to-day work we do, those are still discrete business tasks, right?
Mhm.
Uh, so you want to make sure that, or think about how do you narrow your focus through your GenAI solution to truly solve the actual business tasks you're trying to solve, right? So what does that actually means is as well is you probably don't always want to use the most powerful model because they can solve 100
Mhm.
things, but you only need to solve two things. Now, if I only don't solve two things, I might as well choose a model that solves those two things really, really well. And if I do
Mhm.
that, then number one, I can evaluate my model much more effectively because I know exactly how do I evaluate because I only want to evaluate the two. You can also
Right.
actually, going back to responsible AI part of it, you can also think about how do you detect biases, detect, those different, aspect of the model in a very
Mhm.
focused way so that, you're not boiled in the ocean, right? Just making a decision to go to production not quicker. And lastly, the specialized model tend to be smaller and cheaper as well, right? So
Mhm.
those are some of the different things. I guess challenges, and how do you
Mhm.
think about overcoming those challenges in the Gen AI
Right.
domain?
Right.
But things still moving very fast. I think as new
Mhm.
capability become more and more available, especially in the uh, long-term planning as well as decisioning, reasoning aspect of
Mhm.
thing, the whole landscape of challenge is going to arise differently, and that's going to require a different way of thinking about it as well.
Right. Speaking about the future, we have one question by Vinay Banka. Machine learning in which fields will be more demanding in the future? Do you think you have a take on this, David?
Machine, which field? But I'm assuming by which field do you mean which industry? I just want to confirm.
I'm guessing.
Okay. Uh, First of all, I guess there's in the fullness of time. Let me put it this way, right? Machine learning going to be in high demand, right, in all industry, right? Just because the potential business value is going to bring, right? So I would say that's a longer term view. So hence, like it's important almost for everyone to become, fluent or familiar, right, with what it can do and what does it mean to do it.
Right.
In the short term, if you will, I see some industry that are leading the pack, right? Definitely the high tech technology kind of domain, right? They tend to move faster with adoption. They
Right.
usually come with more advanced use cases. But I also see, a lot of, faster advanced adoption in, financial services, for example, right, where they want to use, this machine learning more and more to really solve financial challenges.
Mhm.
Healthcare, I'm very excited about, the drug discovery space because I feel that is potentially a game
Mhm.
changer because, drug we all know, right? Very expensive, take a long
Mhm.
time. And especially with Gen AI, it has the promise of really reduce the life cycle of a drug discovery. Another area that we all know, right, is maybe auto, which I also find to be fascinating, interesting as well. In terms of autonomous driving and all that. So I would say those are some of the industry that I see potentially, will continue to lead adoption in terms of advancement. But over time, retail, commercial, media, entertainment, telco, energy, right? They all gonna have this
Yeah,
needs, right?
I agree.
Growing needs more and more.
Yeah, for sure. Looks like we don't have any more questions, and I've exhausted my bank of questions too. Um, so I guess I'll do another raffle, and let's choose our last winner for the night. Okay, here we go. Oh, Vinay Banka. Congratulations, Vinay. Please do reach out
Congrats.
to me on LinkedIn. You should find me by the name of Tanya DeCruz. Um, just ping me and I'll make sure you get your copy. Vinay and Savitri, Tanya DeCruz. Or if you can just type Tanya and Pact, you should find me. Thanks a lot, David. The insights you provided, I'm sure they've been gold to everyone who joined. Um, I for sure loved chatting with you, as I did love working with you as well on the book. It was a fun project. And yeah, thank you. And I'll catch you soon.
Thank you. Thanks everyone. Bye.
Thanks everyone who joined. See you guys. Bye bye.